Okay, so now let's talk about the international diversity of views about those risks. There's a lot of debates, as you probably realized, in the media or talking to people or looking on social media. And in particular, there's a wide difference between people who think there is no risk and people who think the risk can be catastrophic. But it's interesting to look at why, where do these differences come from? Also, you have to realize that the risks have to do with things in the future. For the most part, the most high impact risks are regarding systems that don't exist yet. And so, of course, people don't have a crystal ball and know what the future will hold. And so really it's about what sort of AI will we have in a few years or a few decades. Well, we know the trends are very clear that the capabilities of AI continue to advance, and they advance rapidly. These different views mean that people disagree on things like the effect of AI on labor markets, or the effect of AI on cyber attacks, or on biological weapon attacks, or on loss of control. But what we found is that the differences in those views is best explained by the differences in how people think, how fast people think that AI will become more capable. There are also, different expectations about what society will do in order to mitigate those risks and the effectiveness of things like regulation and treaties. So, the central thing is that explains the differences, as I said, is the speed of future progress, and it is uncertain. Now, when we say something is uncertain, something like this is very important. That's going to change the future. From the point of view of policymakers, well, if the scientists don't agree on the speed of the progress that will come in the future, policymakers need to bite that bullet and say, and be prepared for all the cases. Maybe AGI will be there in 3 years, as some people say, or maybe it's going to be 30 years. We need to be ready for all of these options in terms of policy. Okay, so now let's go a little bit more into the risk reduction methods and their limitations. So there's already a number of technical methods to both assess and reduce the risks of general purpose AI. So evaluating the risk is one thing. So is there a problem? Is the AI able to do something dangerous, for example? That's one kind of question, and we can use that to reduce the risks, because if we detect something dangerous, then we might just stop and not deploy this thing or not even continue training it. Reducing the risk is a different thing. How do we change the methods, the AI system itself, to prevent it from doing bad things? Maybe being used to harm people, for example. And it is important that we develop standards for both of these things, because the regulators should be requiring the use of the best methods that exist both for assessing and reducing the risks. Now, unfortunately, the methods that exist currently to both assess and reduce the risks have limitations, and it is important that the regulator understand these limitations. So, for example, we don't understand how the current AI models, which are neural networks, how they make a decision, how they come to a particular output. We understand the code that says how they're trained, but then once they're trained, it's like, you have a child, and maybe we understand the biology of how people grow and are born, but we don't really understand the details of how they, why they do something. And it's kind of similar here. And that's a problem, because when the AI misbehaves, we might not see it coming or know why and know how to fix it. The other problem is the current methods that exist for safety protection are easy to remove, like we're using jailbreak, and especially if you're able to do fine-tuning. So if the weights of the system are available, then it's very, very easy to remove all the safety protections. Okay, so on the assessing, the way that it works now and why it's not great is that we basically ask it many different questions and see if it's going to answer with something bad. So we just test it on various cases. But these are spot checks, and we cannot check every possible question. And it's useful because if we detect something, then we know there's a problem. But there's no quantitative guarantee of safety. And if the spot checks didn't find anything, then it doesn't mean that there is nothing. We only have something to say when we find a problem. If we don't find any problem, it might still be a problem. Okay, so we shouldn't be just looking at the train going. I think that we still have a few years, and there are many things that governments can do in order to mitigate those risks. We need to better understand how these systems work, as I said, and to think carefully about why and how we're going to be developing AI. Is it going to be, for example, applied in a way that's going to favor attackers or defenders in the conflict? So think about cyber attacks. There are variations of the use of AI which could favor more the attacker or the defender. And how are we going to reap the economic benefits of AI is something we can choose collectively as well. Who's going to benefit from it? And how much we invest in research to mitigate the risks. Okay, so this is an interim report that we delivered last month at the Seoul AI Forum. Please have a look, send me feedback. We are going to be working on the larger report for the end of this year. Now, my thought about the big picture. The report talks a lot about the uncertainty on the timeline, which could be extremely rapid. We see here different benchmarks over time, years on the x-axis, and performance on the y-axis. And the black line is human performance. You see on many, many tasks, as time passes, we approach human performance and often get better. So we need to learn to manage those risks as we discussed in our paper with many Chinese colleagues that came out this year on managing extreme AI risks amid rapid progress in science. So what should we do? I think in general, we're not well prepared for these kinds of very rapid changes. For example, think about what happened with COVID. And so we need to start working on preparedness right now. We need to think about international agreements on the regulation on risk thresholds, especially for the catastrophic risk, like loss of control and misuse. We need to do more research, as I said, to better understand the risks and the capabilities and their consequences, and construct plans. What happens if we detect a risk, one of these thresholds, red lines is crossed? We need to commit right now about what we'll do if we detect such problems. And in general, we need to apply the precautionary principle when there's uncertainty about large risks. Okay. One thing that is important is how we invest in different solutions in terms of safety. We should think of a portfolio of projects, research projects, to try to improve evaluation and how to make safer AIs. For example, a number of researchers have been looking into what's called safe by design AIs, where we can get quantitative guarantees. But some methods may be providing stronger guarantees and take more time to develop, and some methods might be easier and to do, and maybe not as safe. But if AGI happens in 3 years, we need to be ready in 3 years. So we need all of these projects to run in parallel. Finally, there's the question of the competition between developers, as talked about in the report, but also between countries. And so there's really a danger of an arm race between different countries. And AI could become a weapon, something used in the military, starting with cyber, but potentially in other weapons. And so we really need to start right now on international discussions to cooperate on safety, but also to think about if there's going to be a treaty, how do we make sure we get compliance, verifiability, and we need to develop technology for this. Thank you.
Thank you so much, Professor Bengio, for sharing your insights, and we'll let you continue on for the rest of your evening. It was an honor to have you.